Alright, hi everyone. So we're going to go into looking at probability, and this is going to be one of the last things that we do in the lead up to your exams. So I would like to spend probably today's lesson, Thursday and Friday on probability, and then after that we're just going to have one or two things to finish off next week, and then we can start revision. So for today, and for all of the probability things, we're going to do all the exercises on My Maths instead of on Google Forms. Just because we'll probably do them in quite a short, sharp way. So there'll be little exercises that you need to get done after every video, as opposed to maybe a bigger one. All right, so the first thing we're going to look at today is experimental and theoretical probabilities. And this is probably all we'll do today. And then we might get kind of 3 things done on Thursday. So be prepared for quite a big lesson on Thursday. And then we'll go through and recap everything on Friday. Alrighty, so here's your, what do we call this thing, heading and your date, and I want you to write down in your book, so the probability is the chance of an event occurring. So when we're talking about probability, that's what we mean. Now, probabilities are generally represented in a couple of different ways depending on what kind of question you're doing. They might be actually represented in words, so you might have words like likely, certain, less likely, more likely, etc., etc. And the other way that they're represented is either as a fraction or as a decimal. And that's fine as well. In fact, that's like kind of ideal. So that's when you want something more exact than just like a worded representation. You might have like a probability is equal to something else. So it might be like equal to, 0.6 or 0.1. And that means you'd have either a 60% probability or a 10% probability. Alrighty, so what we're going to start off with here is I just thought we'd have this is our probability scale. So a probability of 0 means that there's like a no chance of something occurring. And a probability of 1, that's the highest probability you can have, and that's that it's certain, okay, that it's 100% going to happen, whatever that is, okay. And again, if you think of that as a percentage, that would be 0% chance. This would be 100% chance up here. You can't ever have a probability that's more than 1, because 1 is all of the things that could possibly happen. So for example, if we're looking at a really simple example of tossing a coin, if you're tossing a coin, you can either get heads or tails. And those two probabilities together, they're the only 2 things that can happen. There's no third or fourth option, or there's nothing else that could really go on here. So you can't ever have a probability to be more than 100, because you've got a set defined things that can occur. All right. 0.5, probability of a half, that would mean that there's an equally likely chance of something occurring or not occurring. So equally likely that it could happen or it could not happen. 0.75, that's fairly likely that something could happen. Okay, so that's a fairly high probability. We would say, a 3/4 chance of something happening. That's a fairly likely chance. And 0.25 or a quarter, that's not very likely. So right here, not very likely. Okay, so that's kind of how our probability scale works. Perfect. Okay. From here, the next thing we need to look at is how do you calculate the probability of something occurring? And you do that by the probability of an event. An event and an event is just anything that could happen, but the probability of an event is the number of times your event occurs divided by the total possible options. Okay, so we're going to look at the probability of each of these things here. So the first one is tossing a coin and getting heads. So the first thing we want to think about is when we toss a coin, what can happen? Well, we can get heads or we can get tails. So there's 2 possible options, and heads is one of those options. So tossing a coin and getting heads, the probability of getting heads is 1 option out of 2. Right. Rolling a die and getting a 4. Well, if we're rolling a die, we have 1, 2, 3, 4, 5, 6 options. They're all the sides of our die. Okay, and getting a 4 is 1 out of those 6 things. So the probability of getting a 4 is 1 out of 6. Now this one, hopefully some of you play cards and you know what the suits of the cards are. If you don't, there's 4 suits in a deck of cards, and they all have there's all 13 cards in each suit. These are all things that are actually quite important to learn when you're doing probability, because examiners, when you get to say GCSE or something, they might just assume that you all play cards and you know what they're talking about, but that's not always the case. So if you don't know about cards, start playing, learn a little bit, and it'll help your maths a millionfold. Okay, so the things that we can get, the different cards we can get is spades, clubs, hearts, and diamonds. Okay, and then again, there's equal numbers of all of those. Okay, so picking out a card and it's a spade is 1 out of 4. So probability of a spade equals 1 out of 4. And now the last one is the probability that it rains tomorrow. Now this, we actually can't work out based on this information, because you need to know a lot of things to know whether it's likely to rain. I mean, we need to know what the weather was like today. We need to know what month of the year it is. We need to know if it's humid or not, because that adds to whether it's likely to rain. There's so many things that we need to know. So this one, so far, we can't answer because it's not a set probability every time. You're not looking from a set number of options. Okay, so for this one, for the moment, we can't do it. All right. I just wanted to add that one in, just so you know that there's some that you can't do unless you know a certain amount of things about the question. Okay. Next question. Annabelle has 100 pets, 75 geckos, 4 dogs, 20 chickens and 1 cat. Annabelle, I hope that's around about right. What is the probability that I randomly select one of her pets and it's a chicken? All right, so the probability of a chicken is, now there's 20 chickens altogether and 100 pets altogether, so that's 20 out of 100. Now to work that out, we cancel out those zeros. 2 out of 10. Now 2 goes into 2 once and 2 goes into 10 5 times. So that's a 1/5 probability. Or you could do it on your calculator and that would give you 0.2. Okay, so either of those answers are perfect. All right, last question. What is the probability that I select a random day of the week in my head and it begins with a T? All right, well, what are our days of the week? We've got Monday. Ooh, that's not Monday. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So there's 2 days that begins with T's. So probability starts with T equals 2 out of 7. Okay, now I'm just going to change this question. I'm going to say, what is the probability that I select a random day of the week in my head and begins with a T or an S? Okay, so now I'm looking at T's and S's, or S's. So my probability T or S is now 4 out of 7. All right, so that's the first little bit. We're going to go on to looking at experimental probabilities, and then, like I said, I'd like you to have a go at some My Math stuff after that. So just keep watching for a minute, and we're almost done. Okay, here are we. Okay, so experimental probabilities. Now, experimental probabilities, we do the exact same thing, except we use the data that you're given in the question rather than, what you might theoretically expect. So now we're going to go back to our rainy day example. So here it says, in the UK in April, whether it rains or not on 20 days is recorded. So here's our 20 days, and there's a yes or no for whether it rains. What's the probability that it rains on any given day in April? So I'm going to check. So rains, yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the probability that it rains is equal to 12 out of 20, which is the same as 6 out of 10, which is the same as 3 out of 5, okay, just by halving all of those. So 3 out of 5 as a fraction, that is 0.6. So I could also write as a decimal 0.6. Now, what is the probability that it does not rain? Now, when we're doing probability, and we're going to look at this more on what day? Thursday. When you're looking at something does not happening, we use a special little notation for this. We use like a little dash that tells us not. So this is not raining because you got that dash after it. Now from here, if I know that it rained on 12 out of 20 days, that must have meant there was 8 out of 20 days when it was dry, which is the same as 4 out of, which is the same as 2 out of 5. Okay, because it was 3 out of 5 that it did rain, so it must be 2 out of 5 that it didn't rain, which is also the same as 0.4, has it not raining. Okay, now what you should notice from these is that if we do 0.6 plus 0.4 and we add those together, that adds up to 1. And again, that's like I was talking about before, where you can't ever have anything, because on any given day, it either rains or it doesn't rain. You can't have any combination where it kind of rains, or it, or where there's something else that happens. If you're looking at one thing, that thing either happens or it doesn't. Okay, so those things have to always add up to 100%. Alrighty, last little bit. So we've got a basketball player. So these tables, basketball player is practicing shots from the left-hand side and the right-hand side of the hoop. What is the probability that he makes a shot from the right-hand side? So the probability from the right is, now he makes, so there's 12 shots altogether. He makes 1, 2, 3, 4 of those. So 4 out of 12, all right, which is the same as 1 out of 3 if we divide both of those by 4. So that gives us a 0.33 chance that he makes a shot from the right-hand side. Second bit of the question, what is the probability he makes a shot from the left-hand side? Alrighty, well, the probability from the left, he now makes 1, 2, 3, 4, 5, 6, 7, 8 shots from the left. So 8 out of 12, right, which is the same as, we can divide them both by 4 again, so that's 2 out of 3, 2/3, which is 0.67. Okay, so he's double more likely to get it in from the left than he is to get it in from the right. So which should he practice more? Definitely the right-hand side. Alrighty, I want you to go on now and do your My Maths activities. Let me know if there's any dramas, but other than that, all good. Okay, see ya, bye.